Okay, for tonight's homework, I'm going to have you write the 3 key 5 problems and then write down the 6 magic words to let me know you did it. So again, you're going to do this homework on your own paper. You're going to need your own separate paper. So here we go. First problem I'd like you to do is this one. So I'd like you to write and solve this equation for y. So I'm going to do the opposite. I'm going to add 2x to both sides to get rid of that minus 2x. So plus 2x plus 2x, adding 2x to both sides. Those will cancel away. Bring down the y with the 2 with it. Bring down the equal. 2x and 4, you cannot combine those. So I just write 2x first and 4 second. And then now the opposite of timesing by 2, dividing everything by 2. I know that's a little tricky, but those cancel and give you a y equals 1x or 1 over 1x plus 2. The first word is blue. Blue. All right, for the equation for the graph, I need the y-intercept number and the slope. It looks like the y-intercept number is 1, and the slope connecting 2 points is over 1 up 1, or up 1 over 1. If I put those together, that's a slope of 1 over 1 for my rise and run, or 1. So when I put together my equation, the number I get for my slope goes in front of x. My y-intercept number goes right for b. So this line's equation for the graph is 1x plus 1. Now the theme of this whole section is now you have your equations, answer questions. So this says the equation and graph have the same rate of change, same number in front of x, same common difference, same m, same rate of change, same rise and run. Yes, they both have 1s. True. The equation, greater rate of change in the graph. No, for mine, these are equal. So that would be false. The graph has a greater rate of change. Again, you're looking for the bigger number. These are equal. That would be false. And then the rates of change cannot be compared. That is never true. Never pick that one. The second word is whale. So again, remember, if I had a bigger number for here, that means my graph would have had a greater rate of change. If I would have had a bigger number up here, that means my equation would have had a greater rate of change. If they're equal, they're equal. Alright, next problem I'm going to skip to is this table 1 right here. Let me make sure that is the one. Yep. Alright, second problem for the homework. This one again, write equations and answer questions. So for this one, again, the equation from this table I get by finding the rate of change, my slope, my common difference, my m, and put that with the y-intercept. For a graph, I need the y-intercept and its rate of change from doing rise and run. So for the table, to get its slope, that is the number that the y numbers are going up or down. For this tricky one, these are going down by 3. So that's my slope. My y-intercept is this 0, 2 term. For the graph, this one has a y-intercept of 0, 6. This one has a y-intercept of 0, 2. This one has a y-intercept of 0, 6. Those are both its y-intercept numbers. 2 for this one for B, 6 for this one. For the table, to find its slope or rate of change, look at these y numbers here. See how much they're going up or down by. Only focus on those because my x numbers, since they're going up by 1s, I don't need to worry about any division here to define my rate of change. Just focus on your y numbers. For my graph, this should look familiar, going right 2 down 3. Putting those two numbers together correctly, negative 3 on top, 2 on the bottom, that is a slope of negative 3 over 2. Never 2 over negative 3. Now if I put all those parts together, so I can write my equations and answer these questions. The table, y equals this number going up or down by in front of my x. That is my rate of change. That is my change in x over change in y. And right here again I'm saying that because my x's are only going up by 1s, I don't really need to divide. So that's my rate of change. Negative 3 goes in front of x plus this y-intercept number 2. For my graph, this one, for its rate of change, would be negative 3 over 2, never 2 over negative 3. That number goes in front of x, plus its y-intercept, which is 6. Alright, now I can answer questions. Which function has a greater y-intercept? Definitely the graph had a bigger y-intercept number of 6, the graph. And then explain how. You could say it has a bigger y-intercept, or its y-intercept number is larger, or you could write the two equations and label them. This is the equation for the table. This is the equation for the graph. And I could clearly see, oh, the graph has a bigger y-intercept. But again, explain it somehow. Tell me which one. The graph, because it's got a 6. The table, smaller, only has a 2. Next problem. Greater slope. This is where it gets really tricky for this one. Negative 3 is negative 3 over 1. The table or the graph is negative 3 over 2. And they want you to compare. And when you're doing that, that's super close. But that means a negative 3 over 1 would be a steeper line because you're going over just one box when you're going down 3, where negative 3 over 2 means you're going over a little bit further before you go down 3. So that's a little less steep, a little less of a greater rate of change. This one, steeper. It's going down steeper. If I graph this table, it would be over 1 down 3, and you can see that would be a steeper line. Has a greater rate of change. That's tricky. So the greater slope, you would say the table. And again, tell me, show me these slopes. Label them. This is the slope of the table. This is the slope of the graph. Or write the equations and label them. This is the equation for the table. This is the equation for the graph. I could see the slopes for the graph and table have the table going down faster by a tiny little bit. So the table on this one, that is a tricky problem. Alright, the third problem. And the third word is black. Black. Alright, for this one, they want you to write the equation from the table and then answer the questions. So again, for the table, I need to find its rate of change and the zero term. For this problem, I don't have the 0 hour term. I need to go backwards. So here I go. For this table that's given to you, the 0 term, this is going up by 3, going up by 3, going up by 3. That is my rate of change, going up by 3, going up by 3. The fourth word is dog. Dog. Alright, for this one, I need to go back a step. So the opposite going this direction is subtracting 3. So that is my y-intercept, the 0 term. When x is 0, cos is 10. My going up number, that 3 going up each time, that's my slope or my rate of change. And now for this problem, it's having you understand that the 3, that is how much you're paying per hour to rent a canoe. $3 for every hour. So if you rent 1 hour, you spent $3. 2 hours, you spent $6. This 10 is the zero term, or how much you're spending before you even set foot in a canoe, before you started even renting a canoe, or the base charge, or maybe a deposit, or maybe a cost of getting into the canoe rental place. I'm not sure, but this is saying that before you've even started renting a canoe, you've already spent $10. The zero term is your base charge. But then after 1 hour, you spent 13 total. And again, you get that 13 by after 1 hour, you spent $3 plus that $10 deposit you spent. You total of $13 after 1 hour. It's not $13 per hour. That's what they're trying to get you into thinking. It's $3 per hour. So be careful. So now I can answer these questions. Again, knowing that the $3 going up, that rate of change is how much you're spending per hour. The Y term, the zero term, that 10, that's my base charge, how much I'm spending before I've even started renting. So now I can answer these questions. So the price per hour, $13, that's the one they're trying to bait you into choosing. Nope, it's not $13 for every 1 hour. Nope. Base charge, 13 again, they're going to try to bait you into choosing that. The price per hour, $3 in front of X. Yes, for that one, that is true. That's the one. And then you can see base charge 10. That is also true. $10. The fifth word is white. White. All right. The last problem, I believe, second to last problem, is this one right here, which has you find the rate of change and then compare them. So I could see, going back to this first one here, the rate of change for bus number 1 is 50 miles for every 1 hour. 50 miles per 1 hour. To get the rate of change for bus number 2, I look at the graph. So I compare a dot on this line and look over at this distance Y number to see after 1 hour of travel, I could see this went about maybe 70, 75, 70, 80. I would say about 70 right there. I think I write 70. There we go. So it looks like 70 miles for every 1 hour. That's what the graph is showing me. That's this graph's rate of change. 70 miles for every 1 hour. This is proportional going through the origin. If it was up here, y-intercept number not proportional. So it says, which bus has a higher rate of change? Definitely bus number 2, the graph one. Explain how you know. And again, you need to show me, the slope for bus 1 is 50 miles for 1 hour. The slope or the rate of change for bus 2 is 70 miles for every 1 hour. Or explain in words. Bus 1 in 1 hour only goes 50 miles, but bus 2 in 1 hour goes 70 miles. And I saw that from the graph. But again, explain how you know. And again, you could see I'm trying to show you that if I plotted the graph for bus 1, for every 1 hour it would be 50, and you can see it's a less steep line showing a less rate of change. A greater rate of change is 70 for every 1 hour versus 50 for 1 hour. Steeper the line, greater the rate of change. Alright, last problem. This one has you write the equation from the table and the graph and then answer questions, a common theme. So here we go. The equation for Kaylee's County Fair total cost from the graph, I have the y-intercept number right here, or the zero term right here, or after 0 rides, how much she's spending right away, or for this problem, the $4 entry fee to get into the fair. That's what that's showing. After not even riding a ride at all, you've already spent $4. Now for my rate of change, rise over run, my run of 1, my rise up here going up by 2. So don't think it's just going up by 1, going up by 1 box on this graph. is showing it's going up by 2. So if I put those two numbers together, that rise and run, this graph has a slope of 2 over 1, or 2, with its y-intercept of 4. And again, they want you to understand this is showing it's $2 per ride. So if I have one ride, $2, 2 rides, $4. This 4 is your base charge, or how much you've spent after going on no rides at all. Or for this problem, the entry fee into the fare. So I get that from my graph. Y-intercept of 4, slope of 2 over 1. For my table, the y-intercept is the 0 term. So for this one, y-intercept is 1. For my table, the rate of change, my rise and run, comes from looking at the increase from my y numbers versus the increase from my x numbers. But since these x numbers going up by 1, just focus on the y numbers. If these were going up by different numbers, I would have to divide the change in y by the change in x to get my slope. But I don't have to worry about that for this table. Just focus on the y numbers. So going up by 3, going up by 3. So for my table, the equation is 3x plus 1. Again, showing $3 for every ride you're going on, plus $1 base charge, or $1 before you're going even on one ride at all. So again, now I can answer my questions. It costs 3 more to get into the county fair than the state fair. That is true. The county fair costs $4 to get in. The state fair costs only $1. 3 more than that is true. That is 3 more than 1. That is a true statement. Next problem. Kaylee Riley, $5 or 5 rides. Kaylee spent $8 less. A little trickier. So Kaylee, after 5 rides, she spent $14 from the graph. So after 5 rides, Kaylee spent $14 total. Riley, after 5 rides, spent 16. And you could see 14 to 16, definitely not $8 less. So that would be false. Kaylee Riley, after 3 rides, spent the same amount of money. So 3 rides, Kaylee, she spent $10. After 3 rides, $10 total she spent. Riley, after 3 rides, has spent $10 total from the table. So that is true. It costs $4 per ride at the state fair. Careful, again, this is the one they're trying to bait you into choosing. They're trying to hope that you're thinking this is $4 for every 1 ride. Nope, that is not true. Be careful. That is a false statement. This going up by 3, that's how much it is per ride. Be real careful. So that last one is false. They're trying to bait you into choosing that one. In my eyes, probably the hardest problem on the test right here because of how much reading you got to do and writing. So that one, last one, is false. The last word is horse. So hopefully you did these on a separate piece of paper. Hopefully you've written down those 6 key words. Good luck.